Hey, I'm trying to do the homework on one-dimensional kinematics, but I'm stuck. Do you understand those type of problems?
I feel like I understand them from what we learned in lecture, but I haven't started the homework yet. I can try and help you. Which problem are you having trouble with?
I've been stuck on this particular question. You are driving towards an intersection at 18 meters per second. You are at 95 meters from the intersection when the traffic light turns red. Assuming that your reaction time is half a second and that your car brakes with a constant acceleration, what acceleration will bring your car to a stop right at the intersection?
That sounds like a long problem, but I think we can figure it out. How did you start?
First, I drew a picture by picking out the given information. I know there is a car 95 meters from the intersection, and it's traveling at a velocity of 18 meters per second. So I also added a velocity vector in the direction the car is traveling. I know there is also a reaction time of half a second, and the car travels with a constant acceleration, but I don't know how to show that in the picture.
I'm not too sure either, but maybe we should still write it down because it seems important.
Okay. I feel like I'm still forgetting something though.
The axis, so that way we know where the car's initial position is.
Well, the car starts at 95 meters from the intersection. Wouldn't that be the initial position? That means that the origin would have to be at the intersection.
We can make the initial position 95 meters, but I remember the professor saying we can choose where to place our axis to make calculations easier. So why don't we put it where the car starts and make that the initial position? So that way it starts at 0. But what direction should be positive?
I think we should choose positive x to be towards the left because the car is driving that way.
Oh, okay. I like that. It makes things easier even though it seems a little weird.
Oh, I almost forgot. We should call the car's initial position xi and write that it equals 0 meters.
Nice catch. I think we need to figure out the rest of the car's positioning depending on time. You know, if we have an initial position, we need to have a final position too.
Okay, so would the final position be when the car comes to a complete stop?
Yes. Let's call that position XF and write down that it equals 95 meters.
Alright, is that all the important positions? What about when the car starts braking?
You're right. Let's call that XB for when it starts braking, but we don't know what position that is, so we can leave that blank.
Okay, so now that we have all the positions, I think we should write the velocities for each position of the car and the times they happen. At the initial position, we have the initial velocity equals 18 meters per second and the starting time is 0 seconds. Half a second later, at the position where the car starts braking, the velocity is still 18 meters per second. And finally, at the final position, the velocity equals 0 meters per second, since it came to a stop. We don't know how long it takes for the car to go from the braking position to the final position.
Nice. Looks like you're getting the hang of this. Okay, so what's next?
Okay, so now we have everything set up. I think we are ready to start looking at equations. This is a constant acceleration problem, so I guess we use one of the 3 kinematic equations?
Yes, but which one do you think we should use?
Well, I think we should compare what we have to the equations.
Good idea. So the first kinematic equation has the final velocity is equal to the initial velocity plus acceleration times how long the motion takes. We know that the initial velocity is 18 meters per second and the acceleration is constant, so that means it's equal to 0 meters per second squared. We don't know the duration of time or the final velocity. Looks like we have 2 unknowns for this equation.
Wait, that doesn't make sense. I thought the car was braking, so acceleration can equal 0.
I think it's because we've been thinking about this wrong. We need to break up this problem into 2 parts, because if we look at it from the initial to final position, the acceleration isn't constant over that whole area. but it is constant in two parts, from the initial to when the car starts braking, and from braking to the final position at the stoplight.
Oh, okay. So let's start from the initial to braking position. From these two positions, we know the velocity is constant at 18 meters per second, and acceleration will be 0. From that, it's straightforward that the braking position is equal to the initial position, 0, plus the velocity, 18 meters per second, times the half a second that it takes for the driver to react.
What equation did you use to get that?
The one that says that the final position is equal to the initial position, plus the initial velocity times the duration of the motion, plus 1/2 times the acceleration times the duration of the motion square.
That makes sense. So I guess now we know everything about the first part of the motion?
Yeah, so now let's think about the second part. We know both the position when the car brakes and at the stoplight. We also know that the initial velocity when the car brakes is 18 meters per second and the final velocity at the stoplight is 0. We want to find acceleration.
Okay, let's try using the kinematic equation we just used. Final position equals initial position plus initial velocity multiplied by delta t, plus 1/2 times the acceleration multiplied by delta t squared.
But we don't know delta t, do we?
What about the third kinematic equation? Can it help us here? Do you remember what it was?
Is that the one that says that the final velocity squared is equal to the initial velocity squared times 2 times delta x?
Yes. We know that delta x is the difference between the final position and the initial position, so it would be from the stoplight to the braking position. So delta x is 86 meters.
We also know the final velocity and initial velocity, so we can solve for the acceleration.
I'm going to plug it in. I get negative 1.88 meters per second squared. Does that make sense? Why is it negative?
Since the velocity is positive, I think the acceleration has to be negative to cause the car to slow down.
Oh, that's right. Looks like we figured it out.
Yeah, we did. Thanks.